how are we going to do that?
When you measure
Fantastic. When you measure the depth, somebody else can have a ruler and measure the stone size. So you're going to measure the depth first, whatever it might be, and then whatever stone that the ruler's sat on, you're going to reach down, lift that one out, and you've got a stone with your leaves on. Yeah. Then we need to try and measure this to give you a size of stone. So there's a few ways of doing that. It's a funny shape for a starter, it's like a block of cheese. So it's not very easy to sort of measure, say, the length, the longest, and the width, the second longest, and then the depth, and times it all up because it's a funny shape. So it doesn't quite work, it's not like a square or a cube. So we're only going to take one of these measurements along one of these axes, that's what we call that. It's like the Earth spins on its axis, yeah, and it's slightly skew-whiffy. We're going to measure either the length, the longest axis, sometimes called the A-axis, the width, so that's 90 degrees to the longest, that's known as the B-axis, or we could measure the C-axis, which is the depth. So out of those three, A, B or C, which one would you go for? Because we're only going to measure one of those axes. Which one and why? Joe, what do you reckon?
C.
C, okay. Why opting for C?
See how thick the rocks are.
Okay, so you're measuring thickness, or rock thickness. That would be valid. If you're measuring rock thickness, I would go with that. We're after stone size. If I said that the stone size is 20 centimetres, or sorry, 20 millimetres, 2 centimetres, would that truly reflect what's going on here? 2 centimetre size? Not really. So it's A or B. You could measure the length, so the length in this case is 14 centimetres. The width, for argument's sake, is 11 centimetres. So we had 2, 14 and 11. Does it matter? None of them are perfect. If it were me, I'd go for maybe the average. If we average those out, 2 centimetres plus 10 or 11, so that's 13, plus 14, 20, 27 divided by 3 is 11. So I would probably go for the width because that's the average actually, just so happens in this example. So it's perhaps more representative. It's the middle value of the 3, it's the median, yeah? So perhaps that's another good justification for why we're only measuring the B-axis. The other thing is that some people say the B-axis of a stone means more to a river than, say, the length or the depth. Can you think why that might be? If this stone was going to be transported by the river, how does it move along the river? Sort of along its length like that, or along its width, or along its depth? Yeah, it's going to be along its width, isn't it? The middle side. If you roll down a hill, you're rolling down on your width. You don't go head to toe, yeah, or cartwheel it. That's pretty impressive. So, in terms of when you're thinking about traction in the river, it's the B-axis that actually determines whether or not a stone is going to roll over and be transported, depending on velocity. I guess we could measure all 3. But why not? Why don't we want to do that? Waste time. It takes a long time. So it's more efficient to measure 1. And we've hopefully justified why we've only measured the B-axis. Yeah. Once you've measured your stone, we've also thrown in an extra variable, which is the stone shape, which is based on this. So it's a scale called the Powers Scale of Roundness. So I think it was a guy, Mr. Powers, came up with a scale to assess the shape of this rock, all right? And it goes from a scale of 1 to 6, 6 being well-rounded like a golf ball, 1 being very angular, yeah, and everything else in between. So based upon this little scale, you can try to categorize your stone shape. If you didn't have that, it'd be quite difficult, you know, it's cheese shape. It's jagged at one end and round at the other end. Very difficult. So by having this, it standardises our method. So the roundness scale, the Powers scale of roundness, helps to standardise our method of stone shape. Coming over this way. Remind me of your name again, sorry. Lucy. I've asked you that about 3 times. Lucy, what do you think of this? Which stone fits? Subangular she's going for, which is this one, is it? What do you think, Henry? Yeah, he's agreeing, subangular. Anyone else disagree? What do you think, Joe? Subangular, he's going for it. Oh, I'm going to say sub-rounded. Yeah, so what's the problem with the method? Potentially. Yes, your own personal opinion, or it's subjective. So, one disadvantage of this is it's subjective. It's your own personal opinion. However, it's a pretty quick way of categorising the stones. Job's a good one. It's very efficient. And it can be applicable to everyone else on the river who are using the same chart, or even other rivers where people have used this same chart, an international measure of stone roundness.